Hello and welcome. This is the benzylic acid rearrangement. So we've got benzyl. We made that in a previous lab. It's this yellow, light yellow compound. It's a diketone and it has two phenyl groups. In the first reaction, we're going to treat this with potassium hydroxide and ethanol. And then the second reaction is just the workup to, protonate the all the base, right? The hydroxide, ethoxide, and of course the carboxylate. So let me show you how the curved arrow reaction mechanism works. We have hydroxide present. What this does is it's going to attack either one of these two carbonyls. And so remember, the dicarbonyls are especially electrophilic because one of them is an electron withdrawing group for the other one, okay? So it's extremely electron deficient. What you get is the tetrahedral intermediate. And this is where your rearrangement occurs, okay? We don't really have a good leaving group. You could reform the carbonyl and kick off hydroxide, but that would just give you the starting material. So that's why this is in equilibrium. But what you can do is take this bond right here. This pen's not working. Take this bond right here and these two electrons, okay? So these two electrons, this whole group here can migrate over to here and attack the neighboring carbonyl, and electrons go up here. So what does that give you? That gives you a rearranged product, where on the right here we're going to have two phenyl groups. We're going to have O-, we're going to have a phenyl group, and you might be wondering, well, why don't we stop at this intermediate until we add the acid? The reason why is because a carboxylic acid, right, has a pKa of about 5 or something, between 4 to 5. And the pKa of an alcohol has a much higher pKa, okay? So this is an acid, this is a strong base. So what we do in water is there's plenty of hydroxide around. This is going to deprotonate the acid, and the alkoxide essentially is going to become protonated with ethanol or water or whatever is present to give us, after these two steps on either side of the molecule, a carboxylate. Let me draw it in the same kind of orientation here. I think that's still on the screen. Let me move this over a bit. So that's what hangs out after step one, okay? So all of this happens during step one. We have attack, we have rearrangement, okay? And then we have a deprotonation and protonation. This guy hangs around until you add acid. I think it has to boil for like an hour or something like this. So we add acid, and that's going to become protonated to give you the final product here, okay? A neutral alcohol and the neutral carboxylic acid. So it's a pretty cool rearrangement. This was discovered many years ago, and it's kind of a classical experiment we do in organic chemistry. So one other thing I wanted to mention here is the water solubility of things, okay? Things that are neutral are not going to be water soluble. So this guy right here has no formal charge, it's neutral. This guy right here has no formal charge, so it also is neutral. Now, anions, because they're ionic, generally speaking, are going to be more water soluble because of the ion dipole interactions you have with H2O or water, okay? So you would expect this to be more water soluble, okay? If you protonated it, you would get something neutral, which should precipitate out, okay? So this is going to be water soluble. Then when you add H+, it's going to precipitate if you're in water, and then that will allow you to isolate this, okay?